record. Welcome to Algebra 1, Lesson 7-3. We're talking about roots, square roots and cube roots to be exact, and square roots of decimals, even harder. You've probably all seen a square root before, I'm hoping. Raise your hand if you've seen a square root. Have you seen a square root? I'm guessing Carlos has too. This is going to be Friday, January 22nd, by the way. January 22nd, 2021. I don't know why it doesn't write right there. That's supposed to be a 1, but it doesn't let me write. It's so weird. Okay, I don't know what happened. 21. There we go. Our objective today is to Ripley had it first.
Memorize the square roots of squares and the cube roots of cubes. Find square roots and decimals and fractions.
There it is. Good morning, Braden. All right, so you need to have this entire list memorized by Monday. Again, I will be giving you 100 problems that are randomized. You need to be able to recall this information 1.5 seconds per problem, including writing time. So it's going to go fast. Have these memorized by Monday. You will have an infinite number of chances to retake this, although I have to grade them. So don't retake it over 10 times because that makes it harder on me. But if you need to, I will grade it. All right, so you're going to memorize that list for homework. Parts of a radical. This whole unit has been talking about exponents and radicals. So this is kind of the reverse of doing, not exponents, it's just doing powers. How do I say this thing? I guess I should look at my notes to make sure I don't make any mistakes while I'm teaching you. You call this 4 right here the index. This 4 is called the index. And this entire thing, by the way, if I'm referring to the 4th root of 16, this whole thing, I call this whole thing a radical. Radical, man, right? Go back to the 80s, the 70s, I don't know. What year is that? Thank you.
Dude, I can't write.
Radical. The thing that's on the inside part, this 16 right here, maybe I can color code this. The inside part right here is called the radicand. Again, these vocab words, I'm not going to quiz you. If you want to be able to talk to your peers or talk to Mr. Sindel, then you can be like, oh, if the radicand is a perfect square, then I'm allowed to take a square root, which means I have an index of 2. Yes, saying those things makes you sound smart, and I know what you're saying, and your peers hopefully will know what you're saying now that I've taught you the vocab. Again, this is called the radicand. Good one. It's actually with a D, radicand, but there is not a radicand. I love the joke, though. And what is this thing right here, this symbol? If I had to kind of circle just that symbol, just this symbol, it's not called the square root symbol because square root refers to an index of 2. That is called just the radical symbol. I know, we're very imaginative here in the mathematician world. Just the radical symbol. Radical symbol. All right, and I will write this down as well because it is important. And actually, I'm going to be lazy. I'm going to type it out. By default, the index is 2. And this means square root. So what do I mean by this? I mean that if you see something that looks like this, if you see something like square root of 4, it doesn't mean divide by 2. It's asking you what times itself twice. So what times what is equal to 4? X times X, and then the answer is 2. Again, you can divide by 2 and you still get the right answer. But again, if I don't write any index here, look, there's no number there. The index is missing. If the index is missing, assume it is 2. Unless written otherwise. This one has an index of 4 because there's a number there. This one, there's no number. Assume it's 2.
Also, if there's the number, then it's by that number?
Yes, exactly. So let's actually try to figure out what is this even asking. When I wrote the 4th root of 16, by the way, that's how you pronounce it. 4th root of 16. If there was a 5 root, if there was a 5 here instead of a 4, I'd say the 5th root of 16, or the 6th root of 16, or the 7th root of 8 or 16. This question is asking what number multiplied. Yeah, Ripley? Not quite. Multiplied. Good guess. Multiplied by itself 4 times is 16. And I know that you're just probably just copying that down in your notes, but really think about what this question is asking. This question is saying this: x times x times x times x. I'm multiplying x 4 times. Why 4? Because this is a 4 for the index. If I do x times x times x times x, that number has to multiply out to 16. If you thought the answer was 4, you're actually wrong, because 4 times 4 times 4 times 4 is equal to, what is that? 256. You can actually do this one with your fingers, though. Everyone take a guess. It's either 1, 2, 3, 4, or 5. Probably not above 4.
You have the answer.
You have the answer. You can type in the chat too, or you can turn your camera on, and we'll look at your fingers. We're looking at your camera too. And most people holding it up here have it. Let's look at the chat. It just popped up. Yes, it is indeed 2, Jose, and all the people that put 2 up. 2 times 2 times 2 times 2 is 16. So the other way of saying this now is the 4th root of 16 is 2. All right. Let's move down. I'm not going to quiz you guys on memorizing 4th roots. You should maybe know them up to like, I don't know, what's the 4th root of 64? Is that even a question? No, 4th root of, I can only do 16, 4th root of 81, I guess. You don't need to have 4th roots memorized. You really need to memorize cube roots. Those come up way more often. All right, let's try an example. Okay, there's a fraction, and that immediately is scary because fractions are typically harder than not fractions. But you can use your properties of exponents. Properties of exponents state that this is really equal to the square root of 16 divided by the square root of 289. I'm allowed to kind of break the problem apart and apply the square root individually to the numerator and the denominator. And again, you might have to look at your notes and look up above and say, oh yeah, I don't know the square root of 289. Let me go ahead and remember what that is. Try to start memorizing these things. You're gonna have to do it anyway on Monday. Might as well get some practice now. All right, the easier question. Quiet raise hand, class. Square root of 16 is, actually you can just hold up because this is like if it's under 10, you should be able to do it with 2 hands, right? Square root of 16, hold it up or type it in the chat. Let me open up the chat again. Most people have it. They're holding up their hands. Nothing's popped up in chat. The square root of 16, good guess. It's 4. Okay, well, it's still a fraction. Now, what is the square root of 289? Let's just do a quiet raise hand for this one. The square root of 289, Carlos? 17. And there it is, good. And then there are always tricks for how to remember. Oh, how do I remember 289? Well, think of this. 7 times 7 ends with what number? 7 times 7 is 49. Oh, it ends with a 9. If this number ends with a 9, I mean, it's either going to be something that's like a 13, because 3 times 3 is 9, or 17. Those are your only 2 choices, and 13 is way too low. That's 169. All right, so the answer is 417. Box it. You'll have a Khan Academy problem just like this. They'll make you do a square root of a fraction. The trick is take the square root of the numerator, take the square root of the denominator. Let's try it again, slightly harder. Example number 2. Please do this one on your own. It will take you about 30 seconds. All right, quiet raise hand. Who's got this? 1 person has it. 2 people have it. 3 people have it. Ashley, tell us. 19 over 13, and done. So the mathematics is easy once you know how to do it, especially if you had a calculator, but memorizing the square roots, that's the hard part. That's what I want everyone to work on. All right, let's try a slightly different type of example. Example number 3. All right, it's a decimal, which is, I mean, it looks hard because it's not just the square root of 289, which you should hopefully have memorized. Square root of 289 by Monday, I should say. Maybe not by now. You just barely saw that list. All right. So again, spend some time thinking. Don't immediately flip over. What is the square root of 289? Try to remember. Okay. Is it bigger than 15? Hopefully 15 you've memorized is 225. Well, this is bigger than 225, so it's over 15. So let's go ahead and I'm going to do a second problem. What's the square root of 289, Braden? 19. Close, because if you did 19, the way I know that that's not the answer is 9 times 9 is 81. 81 ends with a 1, and this ends with a 9. So good guess, but I appreciate it. You have to start guessing and getting them wrong in order to learn these. That's good. I'm glad you didn't just look at the table. Model, student right there. Okay. You want to take another guess? 17, there it is. Yeah, and then again, 7 times 7 ends with 49, ends with 9. So that is a good guess. And it's over 15 because it's bigger than 225. Okay, well, the square root of 289, by the way, is 1.7. And the final answer is 1.7. But why does that work, Mr. Sindel? Well, if you go over here and you actually did the problem in reverse, if you did what's 1.7 times 1.7, then you go through your multiplication. 7 times 7 is 49, carry the 4. 7 times 1 is 7, add the 4, you get 11. Okay, and then you have a 0 here as a placeholder. 1 times 7 is 7. 1 times 1 is 1. And then I have to add these numbers. Here we go. 9 plus 0 is 0, or 9. 1 plus 7 is 8. 1 plus 1 is 2. And then there's 1, 2 decimal places. 1, 2 decimal places, 2.89. Hopefully you remember multiplication of decimals. Obviously I do. Good job, Mr. Snell. I have to pat myself on the back one. It just means that whenever I take the square root, the decimal jumps twice backwards. That's the main thing I want you guys to take away. So check this out. When I take the square root of this next one, I'm going to jump twice backwards, and well, I should say twice backwards if it was just the normal number 36, which means once forwards when I'm multiplying. If you're at all confused, just move the decimal one place and you'll be fine. All right, well, we know the square root of 36. Ripley, what's the square root of 36? 6. Therefore, this one is going to be 0.6. Done. Box it. Did we do the last one already? Questions? Ooh, that's a great question. What happens if it was 0.06? And again, we can check our work. Let's come over here. And I see Haiti and Jose were saying 17. I forgot to see the chat. Sorry. If I did 0.06 times 0.06, what would happen? 6 times 6 is 36. Carry the 3. 6 times 0 is 0 plus 3. Okay, done. Okay, placeholder value, 0. 0 times 6 is 0. 0 times 0 is 0. So nothing is happening over there. I add these up, I get 6, 3. And how many times does the decimal place move? 1, 2, 3, 4. 1, 2, 3, 4. This would be 0.0036, which is not exactly 0.36. So my generalization for you guys is take the square root as if there wasn't a decimal place, then move it once back. So we took the square root of 17, moved it once back. Take the square root of 6, move it once back. Once to the left, I should say, not back. Back means nothing. Move it once to the left after you take the square root without a decimal place. You'll be fine. All right, in our final example, which apparently we have done before, let's go ahead and just do the square root of 324 first. Square root of 324. All right, you need to be thinking, is that bigger or less than 15? Okay, it's that. Is it bigger or less than 20? Oh, 20 squared is 400. So it's between 15 and 20. But what? What's a number between 15 and 20 that ends with a 4? Look at that ending number. That's kind of indicative of what you're looking for. Indicative. I can't speak. My gosh. Alden, what's the square root of 324? It is indeed 18. Again, it's a number between 15 and 20, just because we know 15, 20, those are the easier ones to remember. That's 225 and 400. And it has to end with 4. Well, 8 times 8 is 64. 64, the ending number 4 matches. That's the only one that matches between 15 and 20, I think. Let me go through them. 1, no. Okay, so 16 would end with 6. 17 ends with 9. 18 ends with 4. That one works. 19 ends with 1. So yeah, the 18 is the only one that ends with the correct number.
You wear that shirt every Friday.
Yeah. And once you guys are in AP Calculus, you guys will design your own shirt and I will wear it every Friday. All right, so if the square root of 324 is 18, then the square root of 3.24 is, Diego? 1.8. Again, move the decimal place once back for the non-decimal part problem, and you've got your answer, 1.8. That's what the homework looks like on Khan Academy. You have 3 homeworks, but you have more than just that because you need to start memorizing your cube roots. So 2 of the homework problems are just trying to make you memorize square roots and cube roots. 1 of the homework assignments is square roots of decimals and fractions. But start memorizing this list. I'm going to go ahead and start making your speed sheets for Monday. You can see what they look like on the board as I work on those. So go ahead and write your summaries now. I'm going to go check these notes off really quickly in about 2 to 3 minutes.
Can we start with something?